everyone, in today's video we are going to do some work with solving systems of equations, and in this video you are going to learn how to graph a system of equations and then identifying the solution set using that graphed system, and then we're also going to use the substitution method to solve systems rather than by graphing. Okay, so let's get going. In our class so far, whenever we have been looking for a solution or solving, we've been looking for the x-intercept. Whether we were looking for the x-intercept on the graph or by solving for x algebraically, we were looking for the solution to that one equation. What is going to be different today is that we're solving for a system of equations or a group of equations. So we're going to be looking at multiple lines on a graph, and we're going to be looking for their points of intersection. Because wherever the two lines intersect, those are our solutions now. Okay, so the first option we have for solving by graphing is or the first method we have for solving is by graphing. So the things we're going to do are graph both of the equations and then look for the ordered pairs. The first question that you need to ask yourself is, what kind of functions are you looking at in the system? Think about their shapes. So in this example, y is equal to 4. That is a horizontal line that goes through y is equal to 4. So I'm going to draw that horizontal line, and then I'm going to go ahead and graph my second equation as well. I'm going to change my color because it's going to make things a little bit easier to see, especially when things get complicated if we have different colors for each. So the second equation, y is equal to the absolute value of x minus 1 plus 1. This is an absolute value equation, which means that it's going to be the V shape that we studied in the previous unit. So we are looking at a V shape that has a vertex at HK, which, recall, when I write the H, I'm going to change the sign. So instead of -1, I'm going to put +1, and then the K value is this number out front. So, outside of the absolute value, so I'm going to put a 1 there. So my vertex for my absolute value function is 1, 1. And then because the a value is 1, I'm going to follow a slope of 1 on the right-hand side. I'm going to then make the left-hand side of my V shape for this absolute value function. And then once I've got that shape, I'm looking at these two lines, two functions and their intersections. So I'm going to change my color one more time, and we are looking at this point here and at this point here. Those ordered pairs are -2, +4, and +4, +4. So those two ordered pairs are going to be my solutions for this first system of equations. The easiest way to solve systems of equations will always be by graphing, because all you have to do is draw the 2 lines or 3 lines or however many are in the system and then look for intersection points. There is a now you try problem on the bottom of this section that I want you to take a moment now to pause the video and try, keeping in mind that this first one, that's an x to the first power, which means it's a linear term. So you are going to have a straight line. And the second one, because of that square, is a quadratic term, which means you're going to be graphing a U shape. If you'd like to use your calculator to help, you can, though you should be able to do both of these without a calculator. So take a moment to graph the two, and then the points of intersection are not pretty on this one. They are kind of ugly. So I want you to use second trace 5 to find each of the intersections. We'll check this one in class when I see you next time. Okay, so hopefully you've paused and have tried that problem. So we are going to advance to the next one, if I can figure out what's going on with my computer here. Give me just a second. All right, there we go. got a little bit glitchy. Okay, so the second method for solving systems of equations is to solve algebraically by using the substitution method. The basic idea here is that we're going to get the two equations solved for one variable. So in this example, you can see both of them say y is equal to, so they're both solved for y. And we're going to substitute in the expression from one to the other. So we're going to take one thing that equals y and substitute it in to the other one where the y is. Or in other words, we're going to set these two equal to one another. We're going to say x squared plus 6x plus 1 is equal to negative 2x minus 14. Because if both of these are equal to y, and y is equal to y, that means they have to equal one another. So then from here, we're going to just solve the equation. Now this one, I see that it has this square here, which means it's a quadratic, it's a U shape. So that means I'm going to have to use one of our 4 methods of solving quadratics, either the square root method, there's graphing too, so technically 5, factoring and the zero product property, the quadratic formula, or completing the square. We've got 5 options here. We're not going to solve graphically because we're working on solving these algebraically. All right, so I see an x squared and I also see an x to the first power on both sides. So that says to me I cannot use the square root method because I have that quadratic term and also a linear term here. So I'm either going to have to factor and use the zero product property or use the quadratic formula if it doesn't factor, or I can force it to factor by using the completing the square method. Either way, with all of those 3 options, I need to get everything on the same side first. So I'm going to add 2x to both sides, and I'm going to add 14 to both sides. That gives me x squared plus 8x plus 15 is equal to 0. Now this one's actually pretty easy to factor, so I'm going to solve this one by using the factoring method. You could plug into the quadratic formula if you'd prefer. You could move the 15 back over to the right and find a perfect number by doing b divided by 2 quantity squared and use completing the square. It doesn't matter here. So I'm going to go with the easiest route, which is to factor. 15 is 3 times 5. And I have to use the same sign, so if I put plus signs on both of these, 3 plus 5 is going to give me that 8 for the 8x. Then I'm going to use my zero product property, so I'm going to say x plus 3 is equal to 0, or x plus 5 is equal to 0. And then when I solve each of those for x, I get x is negative 3, and x is equal to negative 5. Now, in order to get my final solutions, I need to substitute the value into one of the equations to get the other variable, the rest of my ordered pair. I know that one of my solutions is going to have the negative 3 where the x is, the other is going to have the negative 5, but I need to finish my ordered pairs. So looking at these two, I'm thinking the second one, negative 2x minus 14, is going to be easier math, so I'm going to plug into that one. I'm going to plug the negative 3 in first to evaluate. Negative 2 times negative 3 minus 14. Negative 2 times negative 3 is positive 6. And then I have 6 minus 14, which is negative 8. So that means my ordered pair is negative 3, negative 8. And when I plug in the negative 5, negative 2 times negative 5 minus 14, that gives me 10 minus 14, which is negative 4. So I have negative 5, comma, negative 4 as my other solution, my other ordered pair. If I wanted to check my work here, I could check by graphing. So if I graph my first one, that is a quadratic. It's U-shaped, but it is in standard form, which means I have to do a little bit of work here. So I'm going to do, to find my x of my vertex, negative b over 2a, which is negative 6 over 2 times a, which is 1. So that's negative 3 for my vertex. And to find the y, I'm going to plug that negative 3 in. So negative 3 squared plus 6 times negative 3 plus 1. That gives me 9 minus 18 plus 1, which is negative 9 plus 1. So negative 8. So my vertex then, by going back to that beginning of this unit, is going to be that negative 3, negative 8. So I'm going to graph negative 3, negative 8, And then the a value is just 1 in this quadratic. So I'm going to follow that normal standard pattern. I'm going to go over 2 units and go up 4. When I go over 3 units, I'm going to go up 9. And then I'm going to make my other side match. And that gives me my quadratic. Okay, so I've graphed that first one. I need to graph the linear function, the second one. According to that equation, I have a x-intercept that's all the way down at -14, so that's way down here somewhere. And then I have a negative slope of 2, so I go down 2 over 1, which means to the left I'm going to up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. All right, so as I'm drawing this linear function, I saw something really, really nice when I graphed the second one on top of the parabola. This point here and this point here, those are my two solutions because they are where they intersect. And if I look, I've got -5, -4, which checks that previous one, that one here. And this one over here is -3, -8. So that one checks, and those are both my solutions. Okay, now I do want to give you just a quick extension thought here before I set you on the Now You Tries. You can find the roots of a quadratic by graphing. Remember that we can use second trace to find the zeros. We can use our calculator again to find the intersection points if you wanted to use the calculator to simplify or check your work here. So I'm going to bring my calculator back, and I'm going to then plug in, let's see, let's do this x raised to the second power. Let's go up to the y1 too. I'm all over the place today. All right, so x squared minus 3. That is that equation. And I can find the intersection. Now, when this one, when we're finding the x-intercepts, remember you can find where it crosses by doing second trace zeros and setting your left and right bound. But because we're finding where y is equal to 0, the x-intercept, I can also put in a 0 there. And when I go to graph, I get that quadratic that I just put in, and then also the x-axis lights up. If I need to find my intersection points of this system of equations, the quadratic and the linear, I can go to second trace and choose the intersection option 5 and put it on the first curve, the blue line, move it to the second curve, the red line, and then for the guess, go over to where that intersection point is. This is going to give me where the blue parabola crosses the x-axis, the red line. Notice here that I get my values the same as if I had actually done this guess and calculated the final answer here. If you do not like finding zeros with the left and right bound, you can use a system of equations like I've shown you here by plugging in for y in the second equation a 0 to get the line for the x-axis, and then use that second trace 5 to find the intersection. So this will also help you if you want a different way of finding x-intercepts by graphing. Okay, so in this video, you learned how to graph a system of equations by graphing each of the lines, and then identifying the solution set of the graphed system by finding the intersection points. And then you've also solved a system of equations using the substitution method by setting the two equal to one another, simplifying and solving, and then finding the y values of those ordered pairs. Remember, you can always check your work by graphing, and you can always graph in the calculator and find the intersections using the second trace 5 feature as well to find those intersections. So go ahead and try the second Now You Try problem now.